Alright guys, so today we're going to be going over Thevenins and Nortons. In this problem right here, it states to find the VOC, which is the voltage of the open circuit, which equals voltage of Thevenins, and Nortons, which is the current of the short circuit, which equals I Norton. So right here we have a 9 amp current source, a 12 ohm, 2 ohm, 9 ohm, and a 4 ohm, and we're asked to first find the VOC. Now if you look at this right here, the 2 ohm, the 9, and the 4 are all in series, so what we can do is just add those up, and the new circuit will look something like this. The 12 is there. Adding those three up, we get 15. Now if you look here, the current goes around, so that's the 9 amp going both through both branches, the 12 ohm and the 15, so it gets split. Now what we got to do is find the current going through this 15. So in order to do that, what we want to do is do a current divider. So current divider, what you're going to do is the current on the 15 ohm equals the current source, which is 9 amps, times the opposite resistor, 12, over both resistors added. So 15 plus 12, that gets you 27. And that's going to equal, punch it into your calculator, you will get 4 amps. Now to find the voltage of the open circuit, it's simple. It's just the voltage of the 9 ohm, and Ohm's law states V equals IR. So the current, which what we got, 4 amps, times the resistance, which is 9 ohms, 4 times 9, and you have 36 volts, which equals V Thevenin, which equals voltage of the open circuit. So that is your VOC. People have asked me do this in another method. Now you can check your work with node analysis, mesh analysis. Doing it mesh method, what you're going to be doing is creating two arbitrary currents going clockwise. We'll call this current 1, current 2. Now doing mesh method, it involves Kirchhoff's voltage law, V equals IR. We'll start at current 1. 0 equals going up the same direction, but realizing that Kirchhoff's voltage law, you need current times resistance. You need a voltage, that's a current source, so you will have to create an arbitrary another variable, so we'll just call it voltage on the current source, CS. So that will be going up in the same direction. You hit the negative to a positive, so you're gonna hit the negative first, which would be minus voltage of the current source, plus you hit the 12, and you're in mesh 1, so 12 I1, and then since it's in between mesh 2 and mesh 1, you're also going to need to subtract that. So minus 12I2, because it's in between both. You can also write this as 0 equals minus voltage of the current source plus 12I1 minus I2. The first one is always the mesh you're in. So I1 minus I2. That's your first one. Now we go on to mesh 2. And mesh 2, 0 equals, now that you're in mesh 2 and this is shared between the two, it would be a negative 12I1 plus, there's 4 resistors, add them all up, you get 27I2. 27I2. And now, if you look at this, mesh 1, we created that arbitrary I1. So now, that's, by inspection, that's just 9 amps. So the first mesh would just be 9 amps by inspection. So right here, we can substitute the 9 to get negative 12 times 9 equals 108, negative 108. Negative 108 added to the other side, you get 108 equals 27I2. Divide by 27 and you're gonna get I2 equals 4 amps. That's just so we can check, it's what we got up there. We're just doing it a different method. So now we're gonna try node voltage. With node voltage, it is Kirchhoff's current law, which is I equals V over R. Now with this, you're going to want to create some nodes for voltage entering and leaving. As you can see right here, a node is anywhere where there is 3 or more wires connecting. So since this is down the line with the A, we can just call this VA, and this is B, so we can just make this the ground, and then we'll call this VC, and we'll call this VD. Now we will begin by, let's do node VC first. So for that, it's just gonna be C. It will be, it's all currents entering and leaving, so 0, all the currents entering and leaving should equal 0. So 0 equals negative 9 going in, negative 9 plus VC, the node you're at, minus VD over the resistor 12. So VC minus VD over 12 plus, still got this one right here. We gotta do this, do that, So now plus VC minus VA over the resistor, just 2. Now we can go on to the other node, VA, and that one's going to equal 0 equals, it's just VA to the ground, so it would be VA minus 0 over 9. You can also write it as VA over 9 plus, now we got to do this one, so then it's the node you're at, VA minus VC over 2. Let's move on to VD, the last node. 0 equals VD minus 0 ground over 4, also written as VD over 4, plus the node you're at, VD minus VC over 12. And also on here, since the 9 amps is leaving, it would be a positive. There you go. You have your 3 equations for node voltage. And now you're just gonna, if you don't like fractions, a lot of people don't do node voltage because they don't like fractions, but as you can see up here, common denominator would just be 12. So let's break these down and get, after cleaning these up, you get 0 equals negative 1 away. You can move these around so you can have them in order. That way when you punch it into your calculator and as a matrices, you know, you don't get them mixed up. So this is what I got here. Now to punch it in your calculator, just gonna go second matrix, scroll over to edit. It's gonna be 3 by, let's see, there's VA, VC, VD, and then the answer, so that's 4. So it's gonna be a 3 by 4. The first one, you can just do that. It would be a -6 because that's a VA, so -6. The second one would be a +7 VC, so a 7. And then the VD, there's one of them, -1 of them, so then, and then you want to move over the -108 to the other side, so you type it in as 108. Now the second one, there's 11 VA, so 11, -9 VC, -9, and there's no VD, so 0, and there's 0. And then the third one, you have no VA, so 0. You have -1 VC, and then you have 4 VD, so 4. And since the 108's here, you move it over, so it would be -108 there. So you go second quit, second matrix, scroll over to math. The B would be RREF. Click that. Second matrix. Choose the first matrices. Close it. And press enter. There you go. So for VA, we have 36 volts. For VC, we have 44. And for VD, we have -16. And to get VAB would equal voltage of the open circuit, and it would just be the drop right there. So the voltage right here, the voltage drop is 36 volts, and we had confirmed that up there, so we get the same answer, 36 volts. So you use mesh method to find the current, and you use node voltage to find the voltage. Now we're going to be looking for I Nortons, and I Norton equals I short circuit. So between the 2 points that they want, what you want to do is add a line and short out the circuit. So this would be I short circuit. Now, realizing that I short circuit, since there is no resistance going through this wire, and since it's parallel to this 9 ohm resistor, it cancels out. So now the new circuit would just be the 9 amp, the 12 ohm, the 2, and the 4. So that would still be the I short circuit. Now you can see that the 4 and the 2 are in series, so that would just be 9 amps, 12, and 6. This is where the I short circuit is. Now, just looking at this, the I short circuit would just be the current through the 6 ohm resistor, and this only works when there are 2 resistors and the current source. You can do current divider. So I short circuit would equal the current source 9 amps times the opposite resistor 12 over both resistors 18, and that gets you 6 amps. The I short circuit I Norton 6 amps. Now to find the resistor for your final circuit, because as you know, the final circuit looks something like this. It will be a voltage source and a resistor in series, or a current source and a resistor in parallel. So you can show both of them at the end of your work, or we already know we got 36 volts. And then to find the resistor, it's V Thevenin over I short circuit. V Thevenin we got 36, and I short circuit we got 6. So the total resistance in that circuit is 6 ohms. So there's also a second method that you can do to find the equivalent resistance, and that is to remove all independent sources. This only works if your circuit has independent sources. If it has dependent sources, it will not work. So with independent sources, a voltage source would be shorted and the current source would be open. So in this case, since we have a current source, the 9 amps, we would leave it open. There's the 12, so that's the open. There's the 12, that's the 2, the 9, and the 4. So this would be resistant equivalent. So pretending not, since that's an open circuit, the 2, the 12, and the 4 ohm resistors are in series. So you have a total of 12 plus 2 plus 4, that's 18 ohms. So the new circuit would look like this. 18, the 9, and REQ. Now with this, it's fairly simple. 2 resistors, and they're in parallel, you can just do R equivalent equals 18 times 9 over 18 plus 9. Punching that in your calculator gives you R equivalent, just 6 ohms. So that's another way of getting R equivalent instead of doing the I short circuit. But like I said, this way only works if there are independent sources. If there are any dependent sources, it will not work. You'd have to go and do it as I short circuit. Hope this helps you guys.